Wait, check. Hello. 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 I check. Hello. Yes. Thank you, Brigita.
You are in the classroom today, Sanjay?
Yes, ma'am.
Good, good. That's very nice. Madhavan, you were not there yesterday. What happened? Hello? Madhavan, are you there? Kalpagesh, Madhavan, are you there? Hello? Hariharan, good evening.
Good evening, ma'am.
Kalpagesh, good evening. Ashwin, good evening.
Good evening, ma'am.
So since we have already waited for 5 minutes, I will start now. Okay, so yesterday we did 2 methods of preparation of ethers. First, we did how to prepare ethers from alcohols, and then we did how to prepare ethers by Williamson's method. So we did both of them. Now today we are going to do properties of alcohols. Okay, so properties of alcohols. Not alcohol, sorry, ethers. Today we are going to learn properties of ethers. Now the first important thing about ethers is that they are generally volatile.
Ma'am, can you hear me? Ma'am?
Yeah, hello?
Ma'am, yes, ma'am. In the meantime, did you call me, ma'am? Because now only internet came.
Yeah. Okay.
Yes.
Now Hari Raghava also come, I can see him. And I was calling you Madhavan because I was wondering why is it that you didn't come yesterday? What happened?
Because there was a competition, like the
Still
school
competition.
hosted, so I have to go to some other college. That's why, ma'am. And it became so late there. I returned
Okay.
home
Oh,
only 8.
okay. Okay. So first, physical property, 3 physical properties we will talk about. So this is a volatile liquid. Ethers are generally volatile liquids. Okay. The other thing, volatile liquid means their boiling point is, their boiling points are low. Boiling point are low. So why do they have low boiling point? Due to absence of H bonding. Okay, so alcohols, which are isomers, they have hydrogen bonding, but there is no hydrogen bonding in ethers, and so their boiling points are low. Vaishnavi, you are coming straight from school? What happened yesterday? You didn't come? Sanjay, can you give her the mic?
Ma'am, I was not feeling well yesterday, ma'am. That's
Okay. So whatever I taught yesterday was about phenol. So you should just go through the
yes, ma'am. I will go through the video. ma'am.
notes. Okay. So BP, the boiling point of ethers is low, and it is because of absence of hydrogen bonding. Okay, so this I should write in full thing so that if you, so it is boiling point. Are low because of absence of hydrogen bonding. However, they are quite soluble in water. Soluble in water. So general physical properties are in general like alcohols, other than the fact that their boiling points are low because there is no hydrogen bonding in alcohols, in ethers, and just the way you find them in alcohols. Okay, so this is physical properties. Now, I told you ethers are not reactive. They are just like water, very useful solvents for organic chemistry. So they have not many chemical properties, only one important chemical property that we need to learn for ethers. So in chemical properties of ethers, we have to first learn reaction with HI. Halogen acids, mainly we look at the reaction with HI. So what happens when ethers react with HI? So there are two possible reactions for reaction of ethers with HI. So supposing I write a simple ether like CH3, OCH3, methoxy methane. What is this? Methoxy methane. Now this is a simple ether. Why do I call it a simple ether? Because the alkyl group on both sides are similar alkyl. So CH3O CH3 when I reacted with HI. Okay. So what will I get? I will get, you can show it like this. So H goes here and I goes here. Even if I write otherwise, it will be the same because it's a simple ether. So what will I get? An alcohol CH3OH and CH3I. It splits and I get CH3OH and CH3I. If my ether is simple, then there is no problem. One side of oxygen, where you take oxygen, you put H, on the other side you put I, you will get the product. Supposing it was ethoxyethane, then also no problem, C2H5, OC2H5 plus HI, what will I get? C2H5OH plus C2H5I. So I can write a general reaction. The general reaction could be ROR. With HI will give me ROH plus RI. So you get an alcohol and an alkyl halide if I'm using limited amount of HI. Okay, so this is the first reaction in case I'm using a limited amount of HI and it is a simple ether. But if my ether is not simple, my ether is a mixed ether. Okay, so let us look at a mixed ether. So supposing my ether is, first case we will take mixed ether, tertiary butyl group on one side and OCH3 on the other side. Okay, so this is methyl tertiary butyl ether. Okay, so it is, you can name it in another way, 2-methyl 2-methoxy propane. Basically, what you have to see is that on either side of oxygen, there are two different groups. On either side of oxygen, there are two different groups. On one side, I have a tertiary butyl group, and on the other side, I have a methyl group. Okay. So when I have two different groups on either side, then when I add HI, what will happen? Now my problem is I can get two possible products, right? What are the two possible products? One is CH3C, CH3, CH3. And here I break it OH and CH3I. This is one. The other possibility is I could get CH3C, CH3, CH3I plus CH3OH. Which will be the major product? Which way? Which will be the product? Whether this combination I will get or this combination I will get, I will have to understand by understanding the mechanism of this reaction. This is an important one, so please see carefully. So what happens first? The first stage of the reaction is that the first stage of the reaction is you have CH3C, CH3, CH3, and O and CH3 here. And I add H here. Out of this HI breaks to give me H plus plus I minus. So this H comes and attaches here. So as a result, slowly, what is the first step? Addition of a proton on ether. So when a proton adds on ether, I get this H is coming here, or I can write it from the top. It is approaching here. H, and so this carbon is acquiring a positive charge, and here is your CH3. Okay, why does this hydrogen come here? Because oxygen gives it a lone pair. It can form a bond with the lone pair. Now the question is, which bond can break? Can this bond break or this bond break? So on this side, this bond will break first because it will result in the formation of a tertiary carbocation. So this bond will break now and I will get CH3, CH3, CH3 plus CH3OH. Okay, so when one is a tertiary, now when tertiary carbocation is formed, now I minus will come and attach here, and I will get tertiary butyl iodide and CH3OH. So which is my major product? This one will be my major product. So the rule number one for reaction with HI is that on one side, if it is tertiary and on the other side, it is primary, the reaction happens by SN1 mechanism. If it is happening by SN1 mechanism, then carbocation will form. And which carbocation is more stable? Tertiary carbocation is stable. So if I have one side tertiary butyl and one side a primary carbocation, tertiary and primary, then tertiary will form the iodide and the primary will form the alcohol. So what is the rule number one? The rule one is, if my ether, what is the type of ether? If on one side it is tertiary and on the other side it is primary, if the ether is top, TOP, one side tertiary, other side primary, then what will happen? Tertiary will form the iodide. Tertiary will form the iodide and primary will form the alcohol. Okay, so if my ether is top ether, that means one side tertiary, one side primary, then tertiary will form the alkyl halide and primary alkyl group will form the alcohol. Okay, now let us take another example where one side it is primary, both sides it is primary. So the second case is when both sides is primary. That means you have CH3, O, CH2, CH3. Now what will happen? So first, when I react it with HI, first what will happen? This H will come and attach here. H will come and attach here. Now the mechanism is SN2, and iodine will try to have a will attack from the back. Now iodine will prefer to attack methyl from the back. Why? Because here there is less steric hindrance. Okay, whenever the mechanism is SN2, you have to decide based on steric hindrance whether backside attack is possible. So I can attack methyl group more easily. So in this case, can you guess what will be the product? Here I will get CH3I plus CH3, CH2OH. So the bond is going to break here. Why? Because iodine will attack the smaller alkyl group. Okay, so if you have two different alkyl groups and both are primary, the one which has less steric hindrance will form the alkyl halide and the other one will form the alcohol. So that is rule number 2. Now let us take rule number 3, the third condition. In third condition, my ether is on one side, it is a benzene ring, right? O. And on the other side, I have a methyl group, methoxybenzene. And now I reacted with HI. Can you guess what will happen? Any one of you, can you tell me what will happen? Where will it break? Will I get two possible products are there? And I'll write both of them. You tell me which will be the major product. One is I comes here and CH3OH. And the other is I get phenol, OH and CH3I. Which one will it be? Can you guess which one will be the major product?
First one,
Ma'am,
less.
is it phenol, ma'am?
Yes, phenol will be the major product. Can you give me the reason why phenol will be the major product? The reason is that this carbon-oxygen bond is difficult to break. Why? Because these electrons are involved in resonance. So this bond acquires what? In the resonance structures which I drew yesterday, you have seen this acquires a double bond character. And since it acquires a double bond character, it becomes difficult to break. So H, when it comes and sits here, phenol forms more easily. And I, with the backward attack, can form CH3I. So you will get phenol and CH3I, right? So in most cases, the smaller alkyl group, in all cases, in fact, the smaller alkyl group will form the iodide and the larger alkyl group will form the alcohol, except when your ether is top. Then larger alkyl group forms the iodide and smaller one forms the alcohol. Why? Because here the mechanism is SN1. So which one will form iodide depends on which carbocation is more stable. So tertiary carbocation breaks out quickly because it is stable. So the other one forms the alcohol. Did you understand? So this is a little bit, practice is required here because two types of questions are asked. Which combination will give the ether and which ether will give me a product correctly with HI. So there are two different things. You should understand the rules and then you should be able to answer. Now I'll give you a little practice here. So I will write a few examples and you tell me which one, what are the products. So first one I'm going to write here. My ether is CH3, CH2, CH, CH3, and here CH2, and here O, CH2, CH3. Right? Now, which will form the iodide and which will form the ether, alcohol? I want to react it with HI. This is from your book only. Tell me. Now you see on both sides they are primary, isn't it? This carbon here, carbon 1 is primary, carbon 2 is also primary. the two alkyl groups which are attached to the oxygen, they are both primary. So when both are primary, what happens? The smaller one will form the iodide. So what will be the product? The product will be CH3, CH2, CH, CH3 here, CH2, OH. And the smaller one will form CH2I and here CH3, right? So I will come here and H will come here. So you will get this product. Why? The smaller one will have lesser steric hindrance. You can see iodine cannot come and attack from behind because it's large group here. Both are primary, so the mechanism is SN2. And in SN2 mechanism, you have to give importance to steric hindrance. Larger alkyl group will form the alcohol, smaller will form the iodide because iodine has to attack from the back. Now, the second example, let me give the second example. Second example is CH3, CH2, CH2O. And here I have CH3, CH3, and here CH2, CH3. Now somebody should tell me what are the products that I will get if I react with HI.
Good evening, ma'am. Vidisha this side.
Yeah, Vidisha.
Hariharan, Ashwin, and Sai Kalyan, why your videos are off? Sai Kalyan, Ashwin, Hariharan. I hope these are your names which I'm saying and their videos are off.
Yes, three
Ashwin
of them
Shiva,
are
are
in the
you
morning
there for
group.
the class or not? Yes, ma'am. Hariharan, Ashwin, Hariharan, you are not visible.
Hariharan has some problem
Wait.
with this video. Yeah. Yes.
So
You
your
can switch-
videos should be on. If it is not on, ma'am, you can remove them from the class. They don't have to attend the lectures. Moving further, anyone is not switching on the camera while a lecture is on, you don't have to attend the lecture. You can stay home peacefully, do as you want, but you don't have to attend the lecture. Okay? Ma'am, you can carry your class now.
Kind of.
Thank you.
Yeah. Hariharan, is there any difficulty you are having?
Can you see me, ma'am?
Yes, I can see it. I can
Okay.
see it. Ashwin, why did you switch off now? Please keep your camera on. Ashwin, what happened? Is there any difficulty in your camera?
No, ma'am.
Then why don't you switch it on? Switch off the light behind you so that I can see you. Okay, no problem. So now tell me, what is the product that you will get? Sai Kalyan, you answer now, today. Answer, what will you get?
Miss, I'll do and send.
Do it and tell. Ashwin, are you attending the class through your phone or through a laptop?
Ma'am, today phone, ma'am.
Okay. Anyway, you should take down some notes also. Anyone who can do this? Hariharan, can you tell me?
Ma'am, is it iodopropane and 1,1 propane, 1,1 dimethyl propane?
You are saying that I will come here and H will come here?
Yes, ma'am.
No. Now, since I've said no, then obviously you know what is the answer, isn't it? What is the
Yes,
answer?
ma'am.
Here, remember, now here look carefully, which there are two alkyl groups, right? This is one alkyl group, this is the other alkyl group, right? Now, what type of group is this is say 2 and this is 1. Now, one is group 1. Is it primary, secondary or tertiary? Can you tell me? Is it primary, secondary or tertiary?
Group 1 is primary, ma'am.
Group 1 is primary. And group 2 is what?
Tertiary, ma'am.
Tertiary. So when one is primary and the other is tertiary, I told you when it is TOP, then P primary one forms the alcohol. So the answer would be CH3, CH2, CH2OH. And this one will form the iodide. CH3, iodine here, CH2CH. Did you understand? So in this case, what will be the major product? The iodide will be the major product. Why iodide becomes a major product? Because the tertiary carbocation is formed very quickly and then iodine comes and attacks. So OH attaches here, this becomes positive, and after that tertiary carbocation breaks out because tertiary is more stable compared to primary carbocation. Okay, so
Ma'am,
that is, yes, tell me.
ma'am, I actually joined the class like 15 minutes late only, ma'am. I was writing my test. Can you just 2 minutes
Excellent.
what can you say about what these rules?
Okay, I'll go through the rules once again. So we are talking of the reaction of ethers with HI. Ethers with HI. Okay, so
Chemical
let me
reaction of
go back
ethers.
once again. So this is ethers with HI. So when when it is a simple ether, then there's no problem. What is a simple ether where both alkyl groups are same? When it reacts with HI, then one side you get alcohol and the other alkyl groups form the iodide, right? H and I, you form alcohol. And so because both alkyl groups are same, it doesn't matter. Here I took ethoxyethane, I got ethanol and ethyl iodide. Then I wrote a general reaction, ROR. One alkyl group forms alcohol, the other forms iodide. But if my alkyl groups are different, here it is a tertiary alkyl, here it is a primary alkyl. So when they are different, then there are two possible products, right? One is if this tertiary will form alcohol and primary will form the iodide. And the other is tertiary will form the iodide and primary will form the alcohol. Okay, two possible. Now, which product is the major product or which is the actual correct product? Let us understand that. So what happens is that first, when one is tertiary and one is primary, the mechanism is SN1 mechanism. So first step is protonation of oxygen. So oxygen protonates and you get this, what I have written on the right side, H plus. Now after H plus, one of the two bonds should break, right? I'll show it in red now. So there are two bonds here, this one bond and this one bond. Which bond will break? This bond, the bond which breaks, if this bond breaks, methyl carbocation is formed. If the other bond breaks, tertiary carbocation is formed. Tertiary carbocation is more stable, so the bond breaks here. And once tertiary carbocation is formed, then iodide attacks it and you get tertiary iodide and primary will form the alcohol. So I told you the rule is that if your ether is topped, that means one side tertiary, one side primary, then tertiary will form the iodide and primary will form the alcohol. Why? Because the mechanism will be SN1. It will depend on tertiary carbocation forming very quickly because tertiary carbocation is stable. Now, if I have two alkyl groups which are both primary, if both are primary, then the mechanism is SN2, and in SN2 mechanism, H attaches here, and at the same time iodide will try to form attack the carbon. So it will always go and attack the carbon which is less crowded. So here the product will depend on steric hindrance. So since methyl is less hindered, iodide will go and attack this one rather than ethyl. And so methyl iodide and ethyl alcohol is formed. So that means if there are two alkyl groups in ether and both are primary, then the smaller alkyl group will form the iodide and the larger alkyl group will form the alcohol. The third condition is when you have a aryl ether. That means you have a benzene ring on one side and one side it is CH3. Now also you can decide how you can decide based on how quickly this which bond will break more easily. Now here it is easy because this bond is difficult to break. Why? Because it is involved, these electrons are involved in resonance. So this bond acquires a double bond character. So this bond does not break. It will not break. So which bond will break? This one. So this iodine will form a bond with methyl and hydrogen will form the bond with oxygen. So you will get phenol and CH3I. Okay. So overall, what did I say? That in almost all the cases, the iodide is of the smaller alkyl group. If there are two different alkyl groups, the smaller alkyl group will form the iodide. The larger alkyl group will form the alcohol, except, only one except, when your ether is a top. On one side, it is tertiary. Then tertiary will form the iodide. Otherwise, the primary will form the iodide. Okay. So then I did these two examples. Here I have HI adding. Now on one side, this side is primary, this side also primary. So what will decide? Steric hindrance. So here there's a larger group. So this cannot form iodide. So this will form the alcohol. The smaller group will form the iodide. Now we took the next example. Here this is primary and this is tertiary. So once it is tertiary, then tertiary takes over and it forms the iodide and the other one will form the alcohol. Okay. Did you understand now, Sai Kalyan?
Yes, miss.
Now we will take one more example.
What is that special case that you told?
What is it?
The special case that you told where it isn't normal, like 3 degree won't proceed over 1 degree. One special case you except you told, no, miss. Can you say only that again?
So what I am saying is that when one side is tertiary and one side it is primary, then tertiary will form the iodide. Why? Because tertiary carbocation quickly breaks off and carbocation is available, iodide goes and attaches to it. So because tertiary carbocation is very stable, it breaks out from oxygen and then the reaction occurs in two steps like SN1, SN2, I told you. So first step, carbocation is formed. Next step, iodide is formed. When it is SN1 2 mechanism, then what happens? This bond doesn't break. The iodine also is adding and OH is also breaking. So that is why. So what is the way to remember? Smaller alkyl group always forms the iodide in all cases, except when on one side there is tertiary. If it is tertiary, then tertiary will form the iodide. So tertiary is the king. It will always form the iodide. If tertiary is not there, then the smaller one will form the iodide. Okay. Now let us take one more example so that you understand it better. So here I have two benzene rings, right? Here CH2 and here O and now CH3. Now on this side also benzene ring. Here oxygen is directly attached to the benzene ring and right. Now you guess, tell me, here no alkyl groups are there. The difference is here oxygen is directly attached to the benzene ring. Here oxygen is attached to the carbon, which is attached to the benzene. Now I have to break it into two. So what are the two possible products? Okay, one is I could get, this could form CH2I and the other could form phenol. This is case number one. The other is this will form the alcohol and the other one will form the iodide. Now, which is possible? Tell me. Hari Raghav, can you tell me? Is the mic near you, Hari Raghav?
Is it first one?
Yes, correct. The first one, right? Why is it so? The reason is that when oxygen is directly attached to the benzene ring, these electrons take part in resonance and this bond will not break. So where will it break then? Here. So H will come here and I will come here. All right. So that is why. So this was the most important reaction of ethers. Now we will take reactions of ether which are due to the benzene ring. Okay, so electrophilic substitution, which is due to the benzene ring. Now we have already done alcohols, we have done haloalkanes, so you should understand this easily. The first important thing is that OR, okay, when it is ether which has a benzene ring. Now we are looking at what? We are looking at those reactions where which are due to the benzene ring. So you see here, this is the benzene ring, right? And on this place you have OCH3. Now I am looking at those reactions which are due to the benzene ring. Now for that I should know what is the influence of OCH3 on the benzene ring. Now OCH3 group, right? It is ortho-para directing, just like OH group, this is ortho-para directing. If you understand that it is ortho-para directing, then you should be able to write all the reactions of ethers. That is aryl ethers which have a benzene ring, right? So what if I reacted with bromine in presence of ethanoic acid? It's just a solvent. Where will Br come? Can you tell me? Where will Br come on the benzene ring? Anyone? Vaishnavi, can you tell me? Where will Br come on the benzene ring? What is the effect of Br on the benzene ring? It is ortho-para directing. That means the new substituent will come on ortho or para position, right? So which is ortho position, Vaishnavi? Here. So either Br will come here or Br will come on para position. OCH3 and Br will come on para position. Did you understand? Madhavan, are you there? Madhavan has gone. Did you understand? Hariharan, did you understand?
Yes, ma'am.
Okay. All three of you who are sitting there, Sanjay, Hari Raghav, did you understand? Vaishnavi? Yes? Okay. Now, if I take, now you should guess and tell me the product. Now this time I have OCH3 and I am reacting it with CH3Cl. Okay, this is alkylation reaction. What reaction is this? We also call it Friedel-Crafts reaction. Okay, in presence of anhydrous AlCl3. Okay, CH3 should come on the benzene ring. Where will the CH3 go and sit on the benzene ring? Where will the OCH3 is now the director. It will decide where CH3 will come on the benzene ring. So Sai Kalyan, tell me, where will CH3 come on the benzene ring?
Miss, at meta it is the major product. Miss, at para it is the minor product.
Not meta, ortho, ortho. Okay, so it will come on ortho position. This is ortho. Plus CH3 will come on para position. What is the influence of OCH3? It allows the new group. What is the new group? CH3. It will allow the new group to come on which two positions? Ortho and para positions. Why? Because OCH3 is what? Ortho para directing. Right? When we did phenol, I showed you what is the meaning of ortho para directing. When we did chlorobenzene, you knew.
Confused on the reactivity of chrysols and
These are reactions of chrysol, not chrysol. This is a reaction of anisole. It is also known as anisole. This is ethers. This is which type of ether, where one side is the aryl group, aromatic ethers. So for ethers, simple ethers, there is only one reaction, that is reaction with HI. But when there is a benzene ring in the ether also, then there will be reactions due to the benzene ring. So what are the reactions due to the benzene ring? The reactions due to the benzene ring, see children, all of you should understand this. Whenever I have a benzene ring, let me show it to you with benzene alone. This is my benzene ring. This is what you should have learned in 11th. Now, when I have a benzene ring, this benzene ring can show me 4 reactions. These are the 4 reactions which will happen whenever there is a benzene ring. What is the first reaction? It is called halogenation. Halogenation means you introduce a halogen on the benzene ring. Like you can take bromine. You can take bromine in presence of a solvent. Any solvent, here they have taken ethanoic acid. I could take bromine water also. Then what will happen? Or I can take, bromine and FeBr3. These are catalysts which help in the reaction. Then on the benzene ring, what will come? Br will come on the benzene ring. The second reaction, it is known as nitration. What is nitration? When you react benzene with HNO3 and H2SO4, then what will come on the benzene ring? A NO2 will come on the benzene ring. Benzene ring can invite NO2, it can sit on any of the 6 carbon atoms, all are same. The third reaction is called sulfonation, where you react the benzene with concentrated H2SO4. Then what comes and sits on the benzene ring? SO3H. Then there is alkylation. This is CH3Cl and AlCl3. What will happen to the benzene ring? What will happen to the benzene ring? CH3 will come and sit on the benzene ring, right? Just one more I will show you. There is CH3COCl. If I react it in presence of AlCl3, what will come on the benzene ring? COCH3 will come on the benzene ring. All these reactions, they are called electrophilic substitution reactions. Okay, so just remember them like that. Halogenation, halogen will come on the benzene ring. Nitration, NO2 will come on the benzene ring. Sulfonation, SO3H will come on the benzene ring. Then alkylation, CH3 or any alkyl group will come and sit on the benzene. Acetylation, COCH3 will come on the benzene. Now, wherever benzene ring is there and you use these reagents, this product will be formed. Now I will make a change. I will change my benzene ring. You have already done chlorobenzene, right? Chlorobenzene. Now, what is chlorobenzene? There is chlorine already present on the benzene ring. Now, when chlorine is already present on the benzene ring, this chlorine will influence. It will decide. It becomes the director. It will decide where the new group will come. So if I do the same 4 or 5 reactions, let me do all. So 1, 2, 3, 4, and 5. So first let me do chlorination this time with AlCl3. What will come on the benzene ring? Cl will come. One Cl is already there and that will decide where the next Cl will come. So Cl is what? Ortho-para directing. That means the new Cl will come where? On either ortho, the next position is ortho, or on para position. Cl and Cl. Supposing I do nitration. Okay, I do nitration with concentrated HNO3 and H2SO4. What comes on the benzene ring? NO2 comes on the benzene ring. Where will the NO2 come on the benzene ring? On ortho and on para position. So Cl and NO2. Right? If I do alkylation, CH3Cl and AlCl3, then what will happen? CH3 will come on the benzene ring. Where will it come? On ortho or para position. CH3, no, here Cl and CH3 at para position. Cl here and CH3 here. Right? I hope you know that adjacent positions, this position is ortho. This position is ortho. This position is para. This position is meta. And this position is also meta. Supposing I take CH3COCl, then what will come on the benzene ring? COCH3. Where will it come and sit on the benzene ring? On ortho and on para position. Cl and COCH3. So why are the new substituent coming on ortho-para positions? Because Cl is ortho-para directing. All right. Let me take you back to, because many of you were absent yesterday. Similarly, look at phenol. What is phenol? Phenol is also ortho-para directing. OH group is ortho-para directing. Now I'll do all these reactions again. Right? 2, 3, and 4. So first I will do bromination. In presence of carbon disulfide, what will I get? ER will come here. No. OH is already there. Where will Br come? It will come on ortho and on para position. Orthobromophenol and para-bromophenol. If I do nitration, concentrated HNO3 and H2SO4. In phenol, there is another thing. It is very, very reactive. It activates the benzene ring. So in the same product itself, OH. NO2 comes on ortho, both ortho as well as para position. 2,4,6 trinitrophenol. Why did I get NO2 here, here, and here? Because it is ortho para directing. Why this position nothing is happening? Because this position is meta position. And where is my OH deciding? It decides, you go there. Where will it go? On ortho and meta para position, not on meta. Sai Kalyan, are you understanding something now?
Yes, miss. Yes, miss.
Right? Now supposing I do CH3Cl. What will happen? OCH3 has to come on the CH3 has to come. OH is already there. Where will CH3 come? On ortho and on para position. OH and CH3. All right. So all reactions of phenol are like. Now we will go back to our reaction that I was trying to explain of anisole. Okay, so we'll do the reaction of this ether, which we call anisole. So what is OCH3? Methoxybenzene. We also call it methoxybenzene. Right? Now, what is the influence of OCH3? OCH3 is also ortho-para directing. Right? So the same four reactions. What are these reactions of benzene ring? Halogenation, nitration, sulfonation, Friedel-Crafts reaction. So I will do now. So supposing I take bromine in presence of acetic acid, they have given that example. You can take any solvent. So what will I get? OCH3 here. Where will Br come on the benzene ring? On ortho and on para position. Ortho and para position. So ortho bromo methoxybenzene and para bromo methoxybenzene. Supposing I do nitration with concentrated H2SO4 and concentrated HNO3, this is nitration. So what will come on the benzene ring? Nitro group. Where will it come on the benzene ring? On ortho position and on para position, OCH3 and NO2. Supposing I take CH3Cl and AlCl3, you know with this reactant, what comes on the benzene ring? CH3. Where will it come on the benzene ring? On ortho and on para position. Right? And if I take CH3COCl and AlCl3, same way, what will come on the benzene ring? OCH3. What will come on the benzene ring? COCH3. Orthomethoxyacetophenone. Plus this also OCH3 and here on para position. I'll have to rub it to show the para position. Right? So depending on the substituent which is already present on the benzene ring, the substituent will come in that. It will decide where the new substituent will come. Since I am doing this for benzene ring, let me show you something else. Supposing I had nitro group on the benzene ring. Already, nitrobenzene. This is what? Nitrobenzene. Now, what is the influence of nitrobenzene on the benzene ring? It is meta-directing. Right? It is meta-directing. So, you see here, if I do the same reactions, what will I get? If I do bromination, right, in presence of, CCl4, what will I get on the benzene ring? Nitro group is already there. Now, nitro group will decide where Br will come. It has already decided meta. So, Br will come here. All right. You get only one product, meta, because there's no ortho para. So, only meta. If I do nitration of this concentrated HNO3, H2SO4 and concentrated HNO3, Where will the new nitro group come on the benzene ring? Nitro group is already there. The new nitro group will come on meta position. Right? It will come on meta position. So like that, the group which is present on the benzene ring decides where the new group will come on the benzene. Now, how will you know which group is ortho-para-directing and which group is meta-directing? There are ways to find out. You can do it the difficult way by writing the resonance structures and seeing where the electron density is high. You can do an easy way also. What is the easy way of finding whether it's ortho-para or meta? If any substituent is having all single bonds, like which are those OH or CH3, all single bonds, you can see the substituent has all single bonds. CH3 means CH3, all single bonds. Or you have Cl only, or you have NH2, all have single bonds. If there are all single bonds in the substituent, then it will be ortho-para-directing. If it has a double bond, say for example, you have CH double bond O, aldehyde group, or you have C double bond O and OH, acidic group, or you have NO2, where how is NO2 double bond? There is one oxygen with double bond. This is the structure of NO2 group. So here also there's a double bond. Or you take COCH3, this group. All these groups have a double bond. So if within the group there's a double bond, then it will be meta-directing. Okay, so this is the way you can find out whether your substituent is ortho-para-directing or is it meta-directing. Okay. So now we are done with this chapter completely. Now let us do a few practice questions to revise whatever we have done. Okay, so we have completed this chapter on alcohols, and because tomorrow you are having a test on this chapter. Okay, so you have to revise today and do well in the test. Okay, now let me see whether a few questions.
Ma'am,
Yes, tell me.
tomorrow is maths exam only, ma'am. Sunday is only chemistry exam.
Okay, okay, I wasn't sure. Maybe tomorrow. Now we'll do a few questions for revision. Okay, so I want you to tell me how I will make CH3, CH2, OH. You have to tell me the reagents which will convert it into CH3, COOH. Tell me.
Miss KMNO4.
Is it KMNO4 alone?
Not KMNO4 is one of the reagents.
Okay. So KMNO4 and H plus. Okay. Either potassium dichromate and H plus. This has to be oxidation reaction. So you can either take KMNO4 and H plus, or you can take K2Cr2O7 and H plus. Both of them can convert alcohol into an acid. Now, supposing I have to convert alcohol into an aldehyde, CH3CHO. How will I do that? You have to learn these reagents backward and forward. So this alcohol into aldehyde. How will I convert alcohol to aldehyde? There are 2-3 reagents that we can use. Somebody was present who was present in the class yesterday. Hari Raharan, we have done this question yesterday. Tell me which reagents can convert alcohol to aldehyde.
Ma'am, lithium aluminum hydride, ma'am.
No, that is reducing agent. We have to
Oh,
talk of
oxidation, ma'am.
oxidizing
PCC, ma'am.
agent.
PCC, ma'am.
PCC, right? You can use PCC or you can use copper at 573. All these will convert alcohol to aldehyde. Now
Third one is
aldehyde to aldehyde. Third one is lithium aluminum hydride. That is reduction. Here reduction. So lithium aluminum hydride or NaBH4, they can convert aldehyde to alcohol. Here I am converting alcohol to aldehyde. The fourth one, tell me CH3CH 2OH, right? I want to convert it into CH2 double bond CH2. How will I do? Tell me, Sai Kalyan, how can I do that? D, you have to remove water, isn't it? How do you remove water? With concentrated H2SO4 at 170 degrees. All right, do you remember that now? Four conversions I showed you. Then the fifth one, CH3CH2OH. I want to convert it into CH3CH2OCH2CH3. I want to convert it into ether. Then also I can take concentrated H2SO4, but now at 140 degrees Celsius. Okay, at 140 degrees Celsius. Then I want to convert phenol, right, into (2,4,6) trinitrophenol. How can I do it? Just now I have taught you. How can I do it? What reactants are required? Yeah, tell me. Concentrated?
HNO3 and concentrated H2SO4, ma'am.
Concentrated HNO3 and concentrated H2SO4, right? Vaishnavi, your camera had gone. Were you able to see what I am teaching? Please take the mic from Sanjay.
Actually, the battery went off, ma'am. So the laptop switched off. So we were not with you, ma'am.
Okay. So now you see this. Please note this down. I am revising now. So these reagents, please note down the reagents which will bring about these simple conversions. That means ethanol to ethanoic acid, ethanol to an aldehyde, aldehyde to alcohol, alcohol to alkene. Please note it down.
Yes.
Did you understand, all of you?
Yes, ma'am.
Now, these are the next few. So phenol to this one. Now, supposing I want to convert phenol, OH, and I want to convert it into OH and Br. Right? Br I want to bring. So what will I do? Bromine in presence of carbon disulfide. Br will come on ortho and para position, of course, but if this is given already, you have to just write the reactant. So this is one type of question where you will be given, how will you convert this to this? Name the reagent. You have to write the reagents. Okay, so the products will be given and you only have to write the reagent. The next type of questions could be all steps of, you have a roadmap. Reagent is given, you have to write the product. Say, for example, now I have phenol, right? So what I have to do is, from phenol, I need to prepare this one. How will I do it? Now, first I have to get rid of this OH group. So for getting rid of this OH group, what will I do? I heat it with zinc dust. So you will get benzene. Now benzene, what will I do? I will do chlorination. What will I get? Chlorobenzene. And then I will do nitration. Then what will I get? Orthonitrochlorobenzene. So sometimes this type of conversions can also be asked. You should be able to do. Yes.
Can't we directly do chlorination on phenol?
Can we directly do?
Chlorination on phenol.
Yes. You can do chlorination on phenol. Like for chlorine, you will have to use a reagent so that chlorine comes only on one position. But eventually you will have to remove the OH. You have to remove the OH eventually. How will you do that? You can actually, there is one way, but that product is not, yield is not very good.
I will react with NaOH and then with HCl.
If I react it with NaOH, what will I get?
ONA.
ONA, very good. Then what will I do?
And again with H plus.
H plus. Then what will I get?
Chlorobenzene.
Where is Cl? How can you get chloro?
Sorry, miss. HCl.
Okay. So if I react it with HCl, you will not get chlorobenzene. You are saying HCl and you will get chlorobenzene? No, this will not happen. So you have to remove the OH group. Okay, just remove the OH group and then do it. So that is one way of doing. There are other ways also, but this is one way of doing it. Okay.
Okay.
Now this one also is asked very often. Benzene to benzyl alcohol. How will you convert benzene to benzyl alcohol? So first, what will you do? I'll have to put a carbon chain there. So first I'll react it with CH3Cl and AlCl3, right? So what will I get? I will get toluene, right? Now from toluene, I can do chlorination in presence of diffuse sunlight. So chlorination will take place on the side chain. So what will I get? CH2Cl. And CH2Cl with aqueous KOH. I will get CH2OH. Cl will be replaced by OH. Okay, so you have to, I'm doing these questions from your book only. You have to learn to practice them. If you look at the questions in the textbook, you will be able to do the test well. That is a hint I'm giving you. Please, you have to learn all name reactions. What are the name reactions that we have learned? All name reactions were taught yesterday. Kolb's reaction. Okay, revise it from the book, Kolb's reaction. Then you have to learn Reaumur-Tiemann reaction. Right? Then third reaction you have to learn is Williamson's reaction. Right? These are important name reactions which you have to learn with alcohols. Which is the other reaction? Name reactions. You can learn Friedel-Crafts also. Okay, so revise all these reactions from your book. Okay, now we will do the, I'm doing questions from your textbook only. Now a few conversions which are given in your textbook, let us do those. So name propene to 2-propanol. Okay, so it is propene to 2-propanol. How will we do it? CH3, CH double bond, CH2. I want to make it CH3, CH, OH, CH3. Who will tell me?
Water, ma'am.
Yes, just add water in presence of H plus, H2O and H plus. How will I bring about this one?
H2 and OH minus, ma'am.
B2H6 and OH minus. Very good. So you will get anti-Markovnikov product. Then how will I get from this alcohol? How will you get propene? Reverse.
H2SO4, ma'am.
Yes, concentrated H2SO4. Very good. In presence of at 170 degrees Celsius. Okay. Then how will you now let us revise that one. How will you prepare choose a suitable Grignard reagent? Okay, you have to prepare a suitable, choose a suitable Grignard reagent to prepare ethanol. So from CH2 double bond O, I want to prepare CH3, CH2, OH. Which Grignard reagent should I use? Which Grignard reagent will give me this? Anyone? Who will tell me? Which? Tell me.
CH2 double bond O plus CH3 Mg Cl or Br.
Yes, MgCl or Br, anything. Very good. Very, very good. Right? You will get this on the arrow, write H2O and H plus. So the formaldehyde and Grignard reagent, it will give me the primary alcohol. Now tell me, how will I prepare? I want to prepare C6H5CH2OH. Okay. Which are the two reactants? One of them should be a Grignard reagent and one more reactant. Which combination will give me this benzyl
Benzene, ma'am.
alcohol. Huh?
Benzene?
Benzene will not react
Benzene.
with. It is a primary alcohol. So one reactant has to be CH2 double bond O, isn't it?
Yes,
And
ma'am.
which Grignard reagent will it be? Vaishnavi, which Grignard reagent will I take now? C6H5MgBr. Can you make out now? Right? Hari Raghav and Sanjay, are you understanding? Please wave your hand to show me that you are understanding. Are you able to understand, Hari Raghav? Sanjay? Can you wave your hand? Vaishnavi, are you understanding? Wave your hand. Are you understanding? Vaishnavi? Yes, your mic is a little away from you. I can't hear.
Ma'am, can you hear me now?
Yes, can you understand?
Yes, ma'am.
Yeah, you have to revise.
Yes, ma'am.
Now I will write 2-3 alcohols. All of you should tell me which Grignard, what is the combination, one a Grignard reagent and one another compound. So I want you to prepare 2-propanol from Grignard reagent. Then I want to prepare tertiary butyl alcohol from Grignard reagent.
Ma'am,
Yes,
for 2-butyl alcohol, can we do CH3, CH double bond O?
this one, first one. So
Yes, ma'am.
CH3CH double bond O plus.
And CH3 MgBr, ma'am.
Very good.
H2OH plus.
Like Hariharan, you have understood. Now the next answer should be given by somebody else. Vaishnavi, can you give me the answer of the next one? Now tertiary alcohol. Which 2 reactants will give me tertiary alcohol? You take the mic in your hand.
Should it be ketone?
Yes, it will be ketone. Very good. So it will be acetone, this one, plus CH3MgBr. Very good. It will be ketone. Now the third one, who will tell me? Hari Raghav, can you tell? Please take the mic and answer. Keep the mic close to you, then only I'll hear. No, I can't hear you.
1 minute now. I'll do
Yeah.
it.
Now this is what type of alcohol? It is a primary alcohol. If it is a primary alcohol, what has to be one reactant has to be what? Sai Kalyan, are you there?
Yes, miss.
Yeah, tell me. For the third one, what is the answer?
Miss methanol, miss.
Methanol, very good. And which Grignard reagent?
CH3, CH2, MgBr.
CH3, CH2, MgBr, H2O and H plus. Okay. So there will be also questions from Grignard reagent. So you should be able to remember all the 3 rules. Methanol plus Grignard reagent gives primary alcohol. Any other aldehyde plus Grignard reagent, secondary alcohol. And a ketone plus Grignard reagent will give me a tertiary alcohol. All right. Now the next question, similarly, I will again write a few alcohols and you have to tell me from which alkene you have prepared. So I am writing, this is again, right? Then CH3, CH2, CH2OH. And then CH3, CH3, OH and CH3. Now I want to prepare these alcohols by addition of water. All of them condition I know. I want to add water and prepare. On this side, I need some alkene. Which alkene will give me this alcohol? Which alkene? So I have to remove OH and H from the adjacent carbon. I will explain the first one. It will be CH3, CH double bond CH2. So propene on addition of water will give 2 propanol. Now which alkene will give this one?
Propene, ma'am.
Again propene. But we are, this I will add one more H so that this is. I'll make it a secondary only. Now tell me, which alkene will give me? There are 4 carbon atoms. So which alkene will give me this one?
Butene, ma'am.
Butene, very good, butene. All right, 2-butene. Now for the third one, which alkene will give me?
2-methyl
OH.
propene, ma'am.
2-methyl propane. Very good. Hariharan has revised and come today. I am very happy. Keep it up. Okay, so in this test, I expect better marks from all of you. All of you have to do well in this test. Now, any doubt which any one of you has in this, the way to do well is you have to do all the questions which are given behind your textbook. Please try to solve all of them. The more you do, the better you will become in answering this test. Okay. Sanjay,
Yes, ma'am.
are you understanding?
Yes, ma'am.
So do well in the test this time. Okay. All the best to all of you. Vaishnavi, Hari Raghav, Sanjay, Sai Kalyan, Madhavan went away. Ashwin, oh, I completely forgot. Ashwin, how are you? How are you able to understand, Ashwin? You have switched off your
Yes.
camera.
Yes, ma'am.
Okay, so just revise everything, Ashwin, and do better this time.
Okay, ma'am.
Okay. Anyone has any doubt? Vaishnavi, any doubts you have?
No, ma'am.
Okay. So revise and all the best. Okay. So we'll end the class now.
Thank you, ma'am.
Thank you, ma'am.
Okay,
Thank you.
bye. Bye.
Thank you, ma'am.
How far is your home from this place? It is good when you come and sit here. Is it close by? Okay, so it is better if you can come and sit here, then only thing is you all need some mic so that when I talk to you. Okay, then bye. Is there a screen there in front of you? Where are you? Yes, okay.